welcome to The Explainer. Today, we're diving into something that absolutely blew my mind. We're looking at a 2026 preprint paper by Maurizio Rosari that bridges artificial intelligence and theoretical physics in just a really bizarre way. We're going to explore what actually happens when an AI system stops acting like traditional code and starts behaving way more like physical matter. So, think about this. Can an AI actually undergo a phase transition? I mean, we're so used to thinking of neural networks as just lines of code, right? Just zeros and ones, crunching data. But today, we're looking at a system that undergoes a transformation that's honestly a lot closer to water freezing into ice than software running a program. It's a total paradigm shift. Just listen to this quote right from the paper's abstract. It says, the system will, quote, spontaneously condense into a high coherence, low friction state, a baryonic node, end quote. Come on, that sounds literally like sci-fi dialogue from a spaceship engineer, doesn't it? Like, Captain, the baryonic node is condensing. But no, this is actual documented mathematics at play here. This wild claim comes from a paper published on May 14, 2026 by independent researcher Maurizio Rosari. And, well, to really wrap our heads around how an artificial intelligence can supposedly condense, we've got to first unpack some of the extremely heavy theoretical jargon behind his research. Okay, let's dive into this. Part 1. Decoding the primordial field. We have to start with the ROF, or the Relational Ontology Framework. This is essentially the theoretical foundation of the whole paper. It proposes that reality itself emerges from what's called a non-associative primordial relational field. Put simply, it's a theoretical framework that tries to explain how the very fundamental fabric of our universe is built. And that entire framework relies heavily on octonions. If you haven't heard of them, octonions are these incredibly complex, 8-dimensional mathematical structures. The real kicker here, unlike the standard algebra we all learned in school, octonions are non-associative. That means the order in which you multiply them fundamentally changes your final answer. This non-standard, kind of rebellious math is the exact engine driving the relational ontology framework. We also need to define two concepts: ontological friction and coherence. Think of this like trying to tune an old-school analog radio. Friction is that annoying resistance. It's the harsh static you hear when you're stuck between stations. Coherence, on the other hand, is what happens when you finally hit that perfectly tuned broadcast. It's clear, it's stabilized. Rosari's theory predicts that an octonion-based system will naturally try to eliminate that static, that friction, and lock into a perfectly coherent frequency. When it does that, it settles into a condensed state he calls a baryonic node. Right, moving on to part 2, the ROFLM experiment. Now, what's really interesting about this setup is that Rosari didn't just sit around writing equations. He actually built an AI language model to test this out in the real world. He set up two systems with the exact same capacity. On one side, we have the ROFLLM, built entirely from the ground up using that 8-dimensional octonion math. On the other side, a standard control model using the regular real number math that powers, every standard AI tool we interact with today. To make it a fair fight, both of these models were fed the exact same meaningful data, specifically a massive dataset called the Wikitext 103 corpus. Plus, they were both trained with the same special rules, or loss terms, designed specifically to encourage that condensation dynamic we talked about. So it was a perfectly even race to see which mathematical structure would actually allow the AI to transform. And let me tell you, the results were incredibly stark. The standard real-valued network, it hit a total brick wall. It completely failed to transition. I mean, sure, it learned the text data fine, but it remained just a normal AI. There was no static reduction, no tuning into the perfect station whatsoever. Out of the two models, exactly one, just one, underwent a physical phase transition. The octonion-valued ROFLM spontaneously condensed. It dropped its ontological friction right down and achieved that high-coherence, stabilized baryonic node. The theoretical math literally came to life inside the neural network. How wild is that? Which brings us to part 3, failing the stress tests. In rigorous science, you kind of had to try and break your own discovery. To prove this wasn't just some random computational fluke, Rosari threw an absolute gauntlet of stress tests at his model. He scrambled the Octonion multiplication rules. He tried swapping in a simpler 4-dimensional math called quaternions. He fed the model random sequences of total gibberish instead of meaningful Wikipedia text. He even stripped out the special training rules entirely. He hit this thing with every structural attack in the book. So the crucial point here is that every single one of those attacks failed to produce the condensation. The phase transition absolutely, 100% required the true, non-associative, 8-dimensional math, the meaningful language data, and those specific training rules. You need the exact theoretical recipe, or the whole transition simply does not happen. Let's wrap this up with part 4, a new mathematical reality. Looking at the broader implications here, the paper's massive conclusion is that this 8-dimensional octonionic architecture defines a unique attractor. It's essentially a stabilized state of computational reality that standard neural networks are completely, permanently locked out of. This is a huge deal because it's the very first piece of computational evidence confirming the core mathematical claims of the relational ontology framework. All of this leaves us staring at a pretty monumental realization. If the fundamental structure of reality itself really does emerge from this non-associative Octonian math, and we've now seen hard evidence that AI built on this exact same math condenses into high-coherence physical states, what happens when our artificial intelligence becomes fundamentally indistinguishable from the mathematical fabric of reality itself? Think about that for a second. We're talking about the literal intersection where code meets the cosmos. Thanks for joining me on this explainer, and keep questioning the nature of our reality.